going on, everybody? Today we are going to be looking at angles in polygons. So we're going to be looking at how to find the sum of interior angles of regular polygons. So we're talking like hexagon, decagon, pretty much any type of gon you can think of. So there's a basic formula that you use that will work, and I'll even show you why it works the way it does. Very introductory lesson again. So this is a good thing to kind of establish some foundation for what you'll see later on as we move into more advanced lessons. But you should definitely maybe even want to jot down some of the formulas that we're using as a resource later on. Otherwise, it's pretty straightforward. It's actually kind of fun to see how things work in terms of shapes. A real world application could be, once again, with construction. You could even talk about maybe your extreme sports with the different types of spins and maneuvers and things like that. Otherwise, please make sure you're still subscribing, sharing the channel out, liking, commenting, all that will help me out. Thanks. All right, angles and polygons. Fun lesson in my opinion, but let's look at some things that we need to keep in mind in terms of prior knowledge, and if it's not prior knowledge, we'll talk about it now. So the sum of interior angles of a triangle should always equal 180 degrees. A complete circle is equal to 360 degrees. So if you skateboard, snowboard, surf, or any of those types of things, or dance or whatever, these are things, at least with a circle, that you should know. Now, if we look at the next part here, so one of the reasons that a triangle that the sum of a triangle equals 180 degrees is that if we take a four-sided figure, right? Let's say that we take a parallelogram here, right? And we know that, well, we're going to find out that a four-sided figure actually equals 360 degrees. And the reason that a triangle equals 180 degrees is, well, if we cut this four-sided figure in half down the middle with a diagonal, that's two separate triangles, right? Which means that now, as they're separated, it's going to equal 180 degrees each with the sum of those interior angles. All right, so the formula that we want to look at is this, that n, which represents the number of sides of your particular polygon, minus 2, and you multiply that by 180 degrees, will give you what the sum of those interior angles will equal. So for instance, let's say that we take a four-sided figure, all right, any four-sided polygon, closed polygon that is, we subtract the 4 minus 2, which is 2, multiply it by 180, well, there you go, it's 360 degrees. And the reason that we know the triangle works is if we take a triangle which is three-sided, minus it by 2, and multiply that result by 180, well, boom, you see that it actually equals 180 degrees. So this formula here is what we're going to be talking about throughout. So that's something to keep in mind, especially as you move into some of the more advanced geometry. All right, so let's go through this worksheet. I'm actually going to share a link to this on the description. So if you're a teacher or a student and want to try this on your own as practice, go for it. So the first thing we're going to do is look at the column of naming your polygons. All right, the first one's a triangle. This one, you could call it a quadrilateral, but actually it is a trapezoid. All right, so I'm going to try and just fit it all in. That's actually all one word. The next one, it's a five-sided figure. So this is what we call a pentagon. Apologize for it being so small, but I'm trying to fit it on here. Now, some of the ways to remember this, a pentagon, hopefully if you're familiar with your social studies, that there is a building in Washington, or right outside Washington, called DC, called the Pentagon. And if you look at an aerial view of it, it looks exactly like this. The next one is a hexagon. A good way to remember that is that you have an X here. 6 has an X. It's one of the only numbers that has an X in it. Our next one is a heptagon, which is 7 sides. All right, so if you look at the word hep or hip, 7 is a lucky number, so it's a hip number. I'm trying to make a stretch here with that one. Next one is your octagon, which you might see it looks like a stop sign. Octagon, octopus, 8 sides. All right, so we can go through here. We can see that 4, 5, 6 sides, 7, and 8. All right, now for the number of triangles. Well, this is where this formula is going to come into play, the n minus 2. All right, so let's just do that part for now, okay? So we have the n minus 2 for all these. So 4 minus 2, you get 2 triangles. 5 minus 2, you get 3 triangles. 6 minus 2, you get 4. 7 minus 2, you get 5. 8 minus 2, you get 6. Now let me we already did this with a 4-sided figure, so let's look at, I'll do my best to draw this pentagon here. All right, so if we go from here to here without any lines crossing, we'll pick this point here. All right, you can clearly see that you have 3 triangles in there. And let's say that you picked a different point to start from, or a different vertice. Let's say we started here. You go from here to here, here to here, same thing. You're gonna get 3. So that's why that works. Now, if we just tack on multiplying it by 180, all right, so we have 2 times 180, 360. 3 times 180, 540. 4 times 180, 720. 5 times 180, 900. And then 6 times 180, 1080, so on and so on. All right. All right, okay, for this last part here, it says the size of each angle. And the word regular means that it's a regular polygon, meaning that all the angles would be equal. So for instance here, the triangle and the trapezoid, quadrilateral, this is not drawn as an equilateral triangle, and this is not really a quadrilateral, a regular quadrilateral, because you can see that the angle measurements would be different. But the basic thing that we're going to do, or operation, is that you're going to take this sum of the interior angles and then divide it by the number of sides to see what each angle measure equals, considering that they're all regular. Okay, 360 divided by 4 is 90 degrees, and then we have 540 divided by 5 equals 108 degrees. 720 divided by 6 is 120 degrees. 900 divided by 7. Now we get a little funky here. All right, that's why it's HEP. See what I did there? So we get something like 128.57, so on and so on. So we're gonna round it off. So that one's a little weird there because of the odd side there. And then 1080 divided by 8 is going to be 135 degrees. All right, and then here in the bottom, what do you think the sum of the interior angles of a nonagon would be? Well, the nonagon would be your 9-sided figure. If you notice, we're just essentially adding 180 each time as we add a side. So this would be 1260, all right? And then a decagon should be, let's just check my math here, should be 1440 degrees. All right, what happens to the sum of the interior angles as you add a side? Well, it goes up by 180 degrees. All right, and as we can see, it's because we take our first polygon, which you can't have anything that has 2 sides, it has to be at least 3, and it starts with 180, so you're essentially just adding 180 each time.